Mars can be secretly messing up the depths of our oceans. The red planet is 140 million miles away from Earth, so we once thought that it couldn't have much of an impact on us. But that changed recently with the discovery of some kind of butterfly effect. What starts with a small gravitational pull in space ends up creating giant whirlpools down here. This suspicion began when scientists decided to explore almost 300 deep holes drilled in the ocean floor, which were made back in the 60s. Their goal was to understand the strength of deep ocean currents by analyzing sediments. Materials like sand or mud that accumulated at the bottom of the ocean over the last 65 million years. The bottom of the ocean has layers upon layers of sediments. When these layers show a continuous pattern, it means that the materials have been gradually layering over time without any sudden interruptions. In other words, deep currents were calm and stable. But the researchers also noticed a strange pattern. During specific time periods, they couldn't find any records of sedimentation, which means that something else was interrupting this process. The most likely reason for these gaps was the presence of intense currents at the bottom of the sea. Because they were so strong, they probably moved sediments from their original spots. But here's the weird part. All the gaps identified in the study occurred at intervals of exactly 2.4 million years. The data showed a total of 27 gaps. That can't just be a coincidence. So the scientists realized they were not checking simple breaks in the sedimentation process, they were analyzing the presence of cycles. According to experts, the only plausible explanation for them lies in space and is probably the result of something known as the astronomical grand cycles. To understand this process, we first need to mention the Milankovitch cycles. They're named after the Serbian scientist who suggested a century ago that changes in the way Earth moves around the Sun and tilts on its axis can affect Earth's long-term climate. The thing is, the movements of Earth can be affected by many things, including other planets. Normally, our planet's orbit around the Sun isn't a perfect circle, but it's pretty close. However, from time to time, this path is directly affected by the gravitational pull of Jupiter and Saturn. So it's kind of like these two giant planets can pull our orbit, causing it to become more elliptical. Variations like this can affect the amount and distribution of sunlight, changing the climate here on Earth. According to the Milankovitch theory, Earth's climate patterns change in cycles of 405,000 years, 100,000 years, 41,000 years, and 23,000 years. And the theory is that these cycles might trigger the beginning and the end of glaciation periods, also known as ice ages. His theories were actually confirmed in the 70s by scientists who were also looking for evidence of these cycles in ocean floor sediments. Recent calculations have shown that besides the Milankovitch cycles, there are climate changes that follow much slower rhythms. They don't change every tens of thousands of years. Nope. We're talking about periods that stretch out over millions of years. And this is exactly what the astronomical grand cycles that I mentioned earlier are about. We know about such events basically because of evidence based on mathematics and computer modeling. But it is really hard to find any geological proof of the existence of these million-year astrological cycles, or any clue of how they affect Earth. That is, until now. Turns out, what scientists found at the bottom of the ocean could be just the proof we needed. And that's because the 2.4 million period lines up exactly with records of interactions between Earth and Mars. As the two planets chart their orbital paths, their gravitational fields interact in a process known as resonance. Yep, exactly like what happens with Jupiter and Saturn. From time to time, the gravitational forces of the red planet pull our orbit a bit closer to the Sun. And just like the shorter Milankovitch cycles, this grand cycle also affects our climate. In this case, by increasing the solar radiation that reaches Earth, making our planet warmer. To be honest, experts believe that this amount of extra solar radiation that Mars can somehow give us is not that big of a deal. I mean, it's not going to make our planet so hot that it will make us feel like we're stepping onto the Sun. But this slight difference in climate can be enough to change some behaviors on Earth, such as ocean currents. warmer climates tend to produce more frequent major storms, and that often produces sediment-stirring eddies, also described as giant whirlpools, which can reach the seafloor at the deepest parts of the ocean, known as the abyss. Finding those gaps in the deep ocean sediment record is really impressive because it's probably the strongest evidence we have of the astronomical grand cycles. As I mentioned at the beginning of the video, it's all like the butterfly effect. Every 2.4 million years, Mars's gravitational pull shifts Earth's path around the Sun, causing our climate to warm up. And when the planet is warmer, it can lead to the formation of large whirlpools, which end up turning the deep ocean waters upside down. And there's one more thing. The cycles found in the research also line up with already known periods of warmer climate throughout world history, like the famous Paleocene-Eocene thermal maximum. This event took place around 56 million years ago, when Earth was warmed by about 14 degrees Fahrenheit. Loads of theories have popped up trying to figure this out, like a glitch in Earth's orbit or maybe the passage of a comet. But with this new study, it looks like Mars could also be involved in this event. These new findings are pretty convincing and exciting, sure, but scientists still need to do more work to link these possible cycles of climate change with deep-sea currents. I mean, they did a good job of finding an explanation for the sediment gaps, but so far, it's just a suggestion. Their success is really important for the whole scientific community, though. After all, knowing when exactly these astronomical grand cycles happen and how they affect Earth can help us a lot, especially to differentiate when climate change happens due to a natural event and when it occurs due to human intervention. Studying these whirlpools can also provide scientists with crucial insight into how climate change affects ocean circulation. So, another reason why this finding is so crucial has to do with the potential collapse of the Atlantic meridional overturning circulation. In short, this is a system of ocean currents that circulates water within the Atlantic Ocean, being responsible for bringing warm water north and cold water south. This is what brings warmth to different parts of the globe and also carries nutrients necessary to sustain ocean life. However, there are some fears that this system might stop or become too slow anytime soon. If that happens, oxygen-rich surface waters would no longer mix with deeper waters. But the good thing is that this possible link between Mars and Earth gives a positive take on this situation by suggesting that in a warmer world, more intense deep ocean currents may prevent our seas from stagnating. But again, it's just a suggestion. The evidence is still thin. Some skeptical experts like to point out that although eddies have indeed become more active over the past few decades, satellite observations have shown that their currents aren't always able to reach the seafloor and maintain an effective water circulation. For now, all we know is that it's hard to say who is right. Only the following studies will tell.
Well, here you are. You're the first person to set foot on Mars. And your first mission is to explore a place called Jezero Crater. You're wading through the thick, rust-colored dust when suddenly you trip over something and almost fall. You lean closer to examine the culprit and recoil in horror. A skull is staring back at you. Who did it belong to? An ancient Martian dinosaur? A representative of a long-lost civilization? Now, this isn't a made-up story. That's what NASA's Mars robot called Perseverance would tell you if it could speak and, had consciousness. The rover had indeed found something strange, but it wasn't a real skull. It just looked like one. In reality, those were rocks that seemed to be out of place on the red planet. Right now, Perseverance is exploring the edge of a big, empty bowl-shaped area called Jezero Crater. Scientists think that a long time ago, this crater held a giant lake. Perhaps it was even full of tiny life. Since December 2024, the rover has been rolling down a steep hill called Witch Hazel Hill. It's an important mission because this hill might hold secrets about what Mars's weather and environment were like billions of years ago. Anyway, on April 11, 2025, Perseverance stopped to look at a special spot where two types of rock meet. One was light-colored and the other was dark. And right at that spot, scientists saw a weird-looking rock they later named Skull Hill. It stood out dramatically because it was dark and had a sharp shape. But the creepiest thing? It was full of little holes, a real nightmare for those with trypophobia. So NASA shared this discovery in a blog post. They explained that Skull Hill didn't look like the other rocks nearby. The area where Perseverance found these strange rocks is called Port Anson. Scientists think that many of the rocks there didn't originally form in that spot. They were moved from somewhere else an exceptionally long time ago. But how did they move, or what moved them? Now, don't get your hopes up. It doesn't mean we'll find space neighbors on Mars. These kinds of rocks are called floats. They are likely to have traveled a long way across Mars billions of years ago, back when the planet was much warmer and wetter, with rivers, lakes, and maybe even oceans. As the water dried up and the soft ground around the rocks slowly wore away over time, the tougher rocks stayed behind, sitting on the surface. Now scientists are trying to figure out how the strange holes on Skull Hill were made. One idea is that tiny parts of the rock broke off and wore away over time, leaving behind little pits. Another idea is that Martian winds, which carry dust and tiny rocks, might have slowly scraped the surface, kind of like sandpaper, and created the holes. Skull Hill is dark-colored, and at first, scientists thought it might be a meteorite that had come from space. But when they looked more closely at the chemicals in the rock using Perseverance's SuperCam, the results didn't match what you would expect from a typical meteorite.
Nope.
So, scientists now think Skull Hill might be a volcanic rock. On both Earth and Mars, dark volcanic rocks get their color from minerals like olivine, pyrozine, and biotite. If Skull Hill is volcanic, it might have come from old lava flows nearby that have broken down over time. Or maybe it was blasted out of the rock during a huge crash, something like an asteroid impact that dug deep into the ground and pulled up volcanic rock from below. What helps scientists in their research is that Perseverance now has some cool tricks that help it figure out what Martian rocks are made of. That's how we can learn where the rocks came from and how they formed. Lately, the rover has been super busy. In just a few months, it has collected samples from 5 rocks, studied 7 rocks very closely, and blasted 83 rocks with its laser to learn about them from a distance. That's the fastest pace of research since the rover landed on Mars 4 years ago. At least that's what NASA's Jet Propulsion Lab says. Usually, it can take months to find just one interesting rock in a crater. But up on the edge of the crater, aka the rim, cool and strange rocks are popping up all the time. Scientists are especially excited about getting these rock samples back to Earth to see if they'll show signs that life ever existed on Mars. But there's a problem. The plan to bring the samples back, called the Mars Sample Return Mission, is really complicated, expensive, and running into delays. So, for now, the samples are staying on Mars, waiting for their ride home. Hey, Uber! There's another rover that is currently working hard to help us get more information about our neighbor. That's Curiosity, and it might have found a clue about what happened to Mars's atmosphere from billions of years ago, thick and carbon dioxide rich. If the red planet once had warm temperatures and flowing water, what are the signs of all the carbon that should have been left behind? Now normally, a planet like that would have carbonates, minerals made when carbon dioxide reacts with water and rock buried in its soil. But on Mars, very few carbonates have ever been found, which has been a big mystery. Now, scientists might finally have an answer. A new study suggests that iron carbonate, called siderite, may be hidden inside Mars's sulfate-rich rock layers. These layers weren't easy to spot in satellite images from orbit. That might be the reason why carbonates may have gone unnoticed for so long. At one point in the past, Mars's carbon cycle got out of balance. The rocks started pulling in more carbon dioxide than they were releasing. Over time, this may have caused Mars to lose too much CO2 from its atmosphere. It cooled the planet and made it dry and lifeless. The planet might have been still habitable when this happened, but once carbon dioxide started turning into siderite, Mars may have begun getting too cold to support life. The Curiosity rover found these carbon-rich rocks in Gale Crater, an area on Mars that used to be full of water. The rocks also contain a lot of salts, which usually form when water dries up. This supports the idea that Mars went through some huge changes, likely from a planet with a nice climate to the cold, dry world we see today. If scientists find more siderite in other parts of Mars, it could help explain where all that ancient carbon dioxide went. Even better, it would support the idea that Mars was once warm, wet, and maybe even habitable. But that's not the only discovery Curiosity has made. The rover has a set of special instruments called SAM. Now, SAM's job is to study the rocks, dirt, and air on Mars to learn more about the planet. And one of SAM's biggest findings happened when it studied rocks from Gale Crater. SAM found organic molecules. Organic molecules are special because they're made of carbon, and on Earth, carbon is super important for life. Plants, animals, and people are all made from carbon-based molecules. So, finding these molecules on Mars makes scientists wonder if it's another proof that Mars once had life, a long, long time ago. When SAM looked even closer, it found certain patterns in gases like carbon dioxide and methane. These patterns might match what you would expect if tiny ancient life forms were making organic molecules. But there's also another explanation. These molecules might have been made by sunlight reacting with gases in Mars's air. In this case, no life would have been involved at all. On Mars, strong ultraviolet light from the sun can break apart and mix up molecules, creating new ones that eventually land on the ground. So even though scientists don't have a clear answer yet, finding organic molecules is a really big deal. At the very least, it tells us that Mars had the right ingredients for life, even if we don't know yet if life actually existed there. Now, scientists are using SAM and Curiosity's other tools to keep searching for more clues. It looks like a regular beach, but something sets off an alarm blaring in your head. The sand looks too red, the sun is too bright, the wind is all wrong, it's hard to breathe, and there's no water in the ocean. Well, panic not, it's normal, since you're on Mars. For the longest time, we've seen Mars as a dry, lifeless dust ball, a freezing desert where water exists only as ice or vapor. But new research suggests that billions of years ago, it was a totally different place. And instead of endless dust, it may have had something much more familiar to us: sunny, sandy beaches. Scientists from Penn State, UC Berkeley, and Guangzhou University studied radar data from China's Zhurong rover. It started to roll across Mars in 2021. While exploring the surface of the red planet, it found sloping rock formations that looked strikingly similar to the ones found on Earth's coastlines. Those are called foreshore deposits. They form when waves push sand onto a shoreline. But Zhurong wasn't just taking pretty pictures. It also had ground-penetrating radar, a tool that allowed it to scan deep below the Martian surface as it traveled 1.2 miles between May 2021 and May 2022. And it found something pretty wild: layers of sediment sloping down at a 15-degree angle. This pattern is identical to the ones left behind by waves on Earth. And this wasn't from the wind, volcanoes, or anything else. It just looked like a real beach. And that's actually a big deal. Because if there were waves and tides, there must have been a large body of water. That means Mars may have once had just the right conditions for hosting life. Even after 3.5 billion years, the formations are still incredibly similar to beaches on Earth. So there must have been a time when Mars was much more than just a dusty rock in space. After revealing this shocking news, Zhurong's radar scanned 260 feet deep into the ground, discovering sediment layers. They once formed along a path perpendicular to an ancient shoreline, the one that likely existed 4 billion years ago. At the same time, it might not be all that surprising. Back then, Mars wasn't the dry, frozen wasteland we see today. It had a thicker atmosphere, a warmer climate, and plenty of liquid water. And I'm not even talking about some tiny puddle. Beaches don't form without a massive body of water. For waves to shape the land like this, there had to be rivers flowing into a vast ocean. Powerful currents had to be moving sand around. and water had to stick around for a long time. This couldn't be just a brief wet spell. It was a period where Mars was hydrologically active for millions of years, potentially being a place where life could have thrived. This discovery gives even more weight to one theory. It has been puzzling scientists since the 1970s. That's when NASA's Viking spacecraft snapped images of what looked like a shoreline wrapping around Mars's northern hemisphere. But there was a problem. The shoreline was all over the place, with elevations varying by up to 6 miles. Wow, which is nothing like our flat, mostly consistent shorelines we see on Earth. This difference made scientists doubt that a Martian ocean ever existed. For years, scientists have been trying to crack this mystery. In 2007, they suggested that Mars' rotation actually shifted billions of years ago. As the planet's massive Tharsis volcanic region grew, the planet's spin axis tilted, warping the surface. It could explain why the shoreline is so uneven today. In other words, what once was a flat and level landscape got distorted over time. Interestingly, Mars has been dropping hints about its watery past for years. Curiosity found ancient ripples in Gale Crater. There were signs of a long-gone lake. Perseverance is currently studying a fossilized river delta in Jezero Crater. Now, with Zhurong's evidence of an ancient ocean, it all comes together. Small lakes? Check. Rivers? Check. A massive ocean covering the northern lowlands? Quite possibly. Zhurong's mission wrapped up in May 2022 after dust blocked its solar panels. But future missions could still explore those ancient shoreline deposits. Scientists might send new missions to drill deeper into the ground to retrieve samples. Or we could use better radar to map Mars' subsurface in more detail. There's a real hope to excavate those areas in the future and find even more clues about Mars' past. At the same time, NASA's Perseverance rover is already working hard in Jezero Crater collecting samples. Scientists hope that it will bring them back to Earth in the 2030s. While those won't include samples from the ancient ocean, they could still help us find out more about Mars's wetter history. For now, the discovery of ancient beaches on Mars gives us a peek into a time when the planet might have looked a lot more like Earth, with water, waves, and rivers. Now let's speak about the Perseverance rover that's still working on Mars in more detail. It has a special drill on its arm and uses it to scrape off the dust and top layers of rock, making small 2-inch wide circles in Jezero Crater. Once, one of its cameras took a close-up photo, and the image showed that the rock wasn't smooth. It was made of tiny interlocking crystals. The rover used 2 special tools to analyze the rock's chemistry. The results confirmed that the rock, named Rochette, was volcanic. It meant it formed from lava or magma, not from mud and clay, like scientists had expected from a former lakebed. Perseverance, also known as Percy, landed on Mars in February 2021, along with a small helicopter named Ingenuity. It is the most advanced rover ever sent to Mars, following in the footsteps of Curiosity, Spirit, Opportunity, and others. But Percy has a different mission. While older rovers mainly studied Martian rocks and climate, Perseverance is searching for signs of past life. Scientists chose Jezero Crater because it looks like it used to be a lake where tiny life forms could have lived. The rover drills, scrapes, and collects rock samples to study with its science tools. It also saves some samples to bring back to Earth in the future for even closer study. Perseverance has found some surprising things on Mars. Scientists studying the data it sent back have discovered that Jezero Crater has changed a lot over time. Long ago, this area had flowing lava, a lake that lasted for thousands of years, rivers that carried mud and sand, and even massive floods that brought in rocks from far away. It means that Jezero's history is more active and unpredictable than scientists expected. This definitely made it harder to find the sedimentary rocks they were looking for. But it has also revealed new places where ancient life might have existed. Another exciting discovery is that every rock Perseverance has studied so far contains carbon-based materials, the same stuff that life on Earth is built from. NASA's Perseverance rover also carries a special tool called MOXIE, which has managed to make oxygen from the carbon dioxide in Mars' atmosphere for the first time. Over 16 test runs, MOXIE produced about 4 ounces of oxygen. That's enough to keep an astronaut breathing for about 4 hours. It worked even better than expected, making up to 0.42 ounces of oxygen per hour. After running successfully for 2 years, MOXIE completed its final test in September 2023. It brings us one step closer to sending humans to Mars in the future. In any case, back to the discovery of ancient shorelines on Mars. This finding might help us see the red planet with new eyes. Water might have been flowing across its surface for tens of millions of years, carving out lakes, rivers, and even a vast ocean. What else have we misunderstood? Did Martian dinos stroll across the vast green valleys of the planet? Or were those bizarre marine creatures the likes of which we can't even imagine? Well, we don't know yet, but one thing is very likely. Mars had an era of warmth, water, and maybe life. Well, it's official, there is life on Mars. No, it's not a clickbait. Let me break it down for you. Most people imagine extraterrestrial life as little green and, preferably, intelligent people. But we need to distinguish between life and intelligence. When someone tells you there's life on another planet, you probably immediately think about some smart being you can converse with. But life is something different. It's often associated with organic. And NASA's Curiosity rover has found the biggest organic molecules ever seen on the red planet. They were hiding in super old Martian rocks, and I mean about 3.7 billion years old. These kinds of molecules can be leftovers from stuff like fatty acids, which help build cell membranes. It may not be the life we're used to thinking of, but at the very least, the ingredients for what we call life have been there. So, NASA's Curiosity rover has been cruising around a huge crater on Mars called Gale Crater. Scientists think this crater used to be a lake several billion years ago. The rover's main job is to find out if Mars ever had the right conditions for life. And one day, Curiosity drilled into a chunk of ancient mudstone in a spot called Cumberland. It collected some rock powder, and scientists ran a special test on it using a tricked-out oven built into the rover. That oven gets really hot, about 1500 degrees Fahrenheit. Luckily, the experiment's conditions allowed the researchers to cook off molecular oxygen, which limited the risk of combustion. And they found something surprising: chains of carbon atoms, up to 12 atoms long. You can find similar chains on Earth in everything from crude oil to, here we come again, living things. You may say that so far, the discovery doesn't sound too earth-shattering. But wait! Yep, these molecules can form naturally through non-living processes, like reactions with water, heat, and minerals. Hydrogen, carbon monoxide, heat, minerals – well, that's enough to cook up these molecules, even without biology. At the same time, such molecules are also common byproducts of life. Here on Earth, we produce similar compounds all the time, especially as carboxylic acids, which are everywhere in living organisms. So, even though these chains might have formed naturally, they could also be leftovers from something once alive. Maybe microbial life, maybe something way more complex. We just don't know yet. But the most unusual and intriguing thing about the molecules is that these carbon chains are pretty fragile. On Earth, sunlight, air, and water would break them down over time. Yet, they're still on Mars after billions of years. So, even if these molecules don't belong to Martian dinosaurs, we now know that the red planet is good at preserving organic stuff. And this is huge for the search for ancient life. There's a good chance that chemical traces of that life might still be hiding in the rocks, and apparently, Curiosity is capable of detecting them. Now, by the way, this is not the first time Curiosity has found organics. It's also picked up chlorinated organics, sulfur-containing stuff, and nitrates, basically ingredients that, if life ever brewed on Mars, would have been part of the recipe. Now, how about we talk about another hero sent to Mars to make incredible discoveries? Meet Perseverance. It's a car-sized robot NASA once sent far away from home to the inhospitable and dry red planet. In particular, to an ancient crater called Jezero. The Jet Propulsion Lab created Perseverance and prepared it for its first space journey, which started on July 30, 2020. For 7 dark, lonely months, the robot was traveling through the cosmos. Luckily, it managed to land on Mars safely on February 18, 2021. NASA even gave its landing spot a cool name, Octavia E. Butler Landing, after the famous science fiction writer. Since then, Perseverance has been busy exploring the red planet. As of April 8, 2025, it's been active for 1,469 Martian days, which are, by the way, called sols. That's about 1,510 Earth days, or a little over 4 years. The rover looks a lot like its older sibling, Curiosity, but it boasts some upgrades. It's literally loaded with tech: 7 scientific instruments, 19 cameras, and even 2 microphones to record sounds from Mars, like the wind or the crunch of the rover's wheels over rocks. Perseverance also brought along a tiny flying buddy. It's a mini helicopter named Ingenuity. Ingenuity made history by performing the first powered flight on another planet on April 19, 2021. It was only meant to fly a few times, but it kept going and made 72 flights in total. Unfortunately, on January 18, 2024, it got damaged during a rough landing, so NASA officially retired it. As for Perseverance, it has big goals. It's searching for signs that Mars once had life, especially in areas that used to have water. In its search, the rover is trying to figure out if the red planet even had the environments that could have supported life. It's also searching for past microbial life, collecting rock and soil samples to bring back to Earth one day, and testing out cool tech, like making oxygen from the Martian air to help prepare for future human missions. After landing in Jezero Crater in 2021, Perseverance got to work right away, starting with its first campaign called Crater Floor. It drove south from its landing site and explored a spot called Saita. Then it returned to Crater Floor, Fractured Rough, and collected its first rock sample there. This was just the beginning of its exploration of Mars history. In its second campaign, Fan Front, the rover made its way toward an ancient delta where a river used to flow into the crater. Perseverance climbed up a valley to check out higher ground, looking for more clues about the past of the red planet. The third and fourth campaigns, Upper Fan and Margin Unit, had the rover studying rocks that could tell us more about the planet's climate and whether it could have supported life. In December 2024, they started planning Perseverance's fifth campaign, Northern Rim. It's supposed to study the crater's rim, where rocks from deep below the surface were blasted to the top during an impact billions of years ago. Perseverance has made some awesome discoveries so far. It found volcanic rocks on the crater floor that showed they interacted with water. This was a surprise, because scientists thought the rocks would mostly be sedimentary, not volcanic. At a place called Wildcat Ridge, the rover even found signs of an ancient lake that could have supported life. The rocks Perseverance has found are great at preserving potential signs of past life, so this is a really big find. The rover has also discovered some of the sediments in the delta were deposited by calm waters, but later massive floods brought large boulders into the crater. It means that Mars's climate must have been changing over time. Now, on top of that, Perseverance has done a few cool experiments. The MOXIE experiment managed to produce about 4 ounces of oxygen from the Martian atmosphere. It could be really helpful for future human missions. The rover also used its microphones to study sounds on Mars. It turned out that sound traveled more slowly there than on Earth. Plus, it was quieter on the red planet. The rover's Pixel tool analyzed rocks and found a bunch of minerals like ovoline, clays, and carbonates. This discovery showed that water had always played a big part in shaping Mars. The RIMFAX radar also helped the team see that the crater floor was made up of solid rock and volcanic material, and that the delta had formed in a calm lake-like environment. All in all, Perseverance has been giving us a much clearer picture of Mars's past. It's discovering evidence of volcanic activity, water, and environments that could have been suitable for life. It's also helping scientists gather crucial data for future missions. By studying the planet's geology, atmosphere, and potential for life, Perseverance is setting the stage for future exploration, and one day, maybe even for humans to walk on Mars. Like the little engine that could, NASA's Curiosity rover has been bravely crawling over Gale Crater on Mars, trying to see what could have happened billions of years ago that made the planet a red desert. And it looks like it might have finally stumbled upon something. While life seems impossible on Mars now, eons ago, it may have been a world more like Earth, with a thick atmosphere, water, and maybe even life. And it seems things changed just recently. Studies show that just 3 billion years ago, the northern hemisphere of Mars might have hosted a stable ocean. On Earth, the Archean Eon was in full swing. Volcanoes were going crazy, and life was taking its first steps. Life was also perhaps taking its first steps on Mars. No, not a frozen wasteland like Antarctica, but in a body of water like an Earth ocean. And this Earth-like climate extended Mars's habitable period by about 500 million years more than we thought before. In other words, there was a 500 million years where it was exactly like Earth, with conditions just right for life to start forming. But then, something happened that changed things forever. The atmosphere thinned, Mars lost its oceans, and became the cold, desolate place we see today. It's been a mystery for a while, but now, Curiosity stumbled upon something interesting in the Gale Crater, a vast basin on the Martian surface where billions of years ago, water once flowed freely. It found carbonates, stuff that can tell us all about the ancient Martian climate. There are minerals that form when carbon dioxide, or CO2, dissolves in water, which means that, to create them, you need two things: a nice thick atmosphere and liquid water. Now on Earth, CO2 is super important because it helps trap heat from the sun in our atmosphere. This keeps our planet warm enough to support life. Plants eat it during photosynthesis to create oxygen, which humans and animals need to breathe. On Mars, the presence of CO2 shows that there really was some kind of climate system. When CO2 starts dissolving in water, it reacts with certain minerals in the ground, like calcium or magnesium, and creates carbonates. That's kind of how seashells form in oceans here on Earth. But instead, it's happening with rocks on Mars. And this discovery is huge. These carbonates act like fossils of the planet's ancient climate. They store information about what Mars was like long ago. By studying them, scientists can get a peek into Mars' past back in the day when water was present. They can tell us how the Martian atmosphere has changed over time, show whether the atmosphere was warm or cold, or if there was a lot of water around, and what happened to the planet in general. Luckily, Curiosity can study this stuff right there. It has the sample analysis at Mars and tunable laser spectrometer. Those are like Mars's forensic tools. The SAM is a mini lab on wheels, and it's capable of heating Martian rock samples to extreme temperatures. There are 2 ovens that can heat samples to about 1,800 degrees Fahrenheit. This intense heat causes rocks to release gases trapped inside, the ones that are like ancient fingerprints of Mars, atmosphere. Once they're released, the TLS analyzes them in detail, breaking them down to the tiniest parts. And what the scientists discovered blew away all our previous assumptions about Mars' habitability. Turns out, it's not just about Mars once being wet, but there was something that led to the gradual drying and cooling of the planet. In other words, Mars's water didn't just disappear. It evaporated quickly under extreme conditions. So, what happened to it? Astronomers produced 2 possible explanations. The first one says that Mars went through periods where it was sometimes wet and sometimes dry. The water didn't last a long time. It may have appeared in short bursts, with periods where it would dry up and then return. The second possibility is more intense. The water that was there was incredibly salty and cold, so instead of being liquid, it was mostly frozen in ice. This would have made the planet way too harsh for life as we know it, since the conditions would have been too extreme for anything to survive. Both possibilities sadly mean that Mars wasn't cozy and full of life in the past like some hoped. Well, at least not on the surface. That doesn't mean underground life couldn't exist, though. This one is still a possibility. And to find more, we must keep looking for hints of water now. Actually, after years of exploring Mars, scientists have just made a mind-blowing discovery. Deep beneath the rocky surface of the red planet lies a hidden reservoir of liquid water. Real water this time, not the frozen ice caps or vapor in the atmosphere, though it's miles below the Martian crust. This breakthrough comes from data collected by NASA's InSight lander. This guy spent 4 years listening to the subtle tremors of Mars. You know, Mars quakes. And it analyzed over 1,300 of them. Thanks to this, scientists were able to map out how seismic waves move through the planet. And it revealed pockets of liquid water buried 6 to 12 miles underground. Not just one lake, but puddles. So they used the same methods we here on Earth use to find underground water, oil, and gas. And they were able to piece together the Martian underground system. You see, as the water disappeared and dried out, some of it escaped into space when Mars lost its thick protective atmosphere. However, this discovery shows that much of the water didn't disappear. It just sank deep underground, where it still lies today. So close, but out of reach. That's a huge step forward. Water is the most important molecule when it comes to shaping the destiny of a planet. And also, even though we said that Mars wasn't filled with life before, this doesn't take away the possibility of it having life now. If liquid water still exists deep underground, could there be some little microbes hiding there as well? Life as we know it can't survive without liquid water. And now, with this, the idea of life on Mars has become more plausible than ever. There's a catch, though. While this water may seem like a jackpot to future Mars colonization plans, it's not going to be easy to reach. To say that drilling 6 miles deep into the crust is no small feat is an understatement. Just so you know, here on Earth, the deepest we've drilled is about 7.5 miles. It was in the Kola Super Deep Borehole project. And this project pushed current technology to its limits. Intense heat, pressure, equipment failures, you name it. With Mars, that would be even crazier. It has a much colder environment, extremely thin atmosphere, and lack of infrastructure. That would make any drilling mission extremely difficult. To reach water reservoirs buried so deep on Mars, we would need specialized drilling equipment that would somehow get delivered there. It should also be able to handle extreme cold, low pressure, and different gravity. Oh, and it should all operate remotely and preferably not break, all while it needs tons of energy. Yeah. Now, it's possible that we would only be able to do this in the future when we'll have automated systems or astronauts on Mars. That's not a quick task for even the most ambitious billionaires. So, for now, what these reservoirs hide is a mystery. But at least it's not the only one. As we mentioned, Mars hides one of the greatest secrets beneath its frozen southern pole, another buried vast lake of liquid water. The radar revealed it as it scanned the ice cap in this region. Hey, just don't make me pronounce it. Now, it's weird that it managed to stay liquid with such low temperatures. It's probably because of the geothermal heat beneath Mars' surface, and life could be there too. So now they're thinking about probing this lake first. That would be much easier. Curiosity's work is incredible, and it keeps helping us peel back the layers of Mars' ancient climate, giving us new pieces to the puzzle of what happened to our neighbor. And this could help us avoid similar mistakes in the future.
And we have liftoff of the Mars Global Surveyor as America begins its journey back to the Red Planet.
There's a weird structure on Mars, a square. A near-perfect square standing alone in the endless red desert. And it looks too perfect, too precise to be anything but artificial. Nature's chaotic, and it rarely makes things look so deliberate. So the internet took one look at it and lost its mind, as the internet tends to do. The image spread like a virus on social media, igniting every conspiracy theory you can think of. Some were convinced it was proof that intelligent life had once tread upon the Martian sands. Well, let's dive in and sort it out. The image is real, and it's really old. The thing, not the picture. NASA's Mars Orbiter camera snapped it in 2001, capturing a tiny slice of Martian terrain, and there sat the square. Now, is that evidence for intelligent life? Well, Mars is an empty world now, a rust-colored desert. But once, long ago, it may have been something else entirely. A planet filled with roaring rivers, vast oceans, and thick clouds rolling across the sky. Now, in a world like that, life, if it ever had a chance, could have taken root. And there's a possibility it did. Scientists think that life could have existed on Mars in a short period from around 4.1 to 3 billion years ago. It could have started during the early era of Martian history, called the Noachian period, and lasted all the way to the late Hesperian period. Meanwhile, here on Earth, the first oceans were just forming. Life on our planet was just beginning, in the form of tiny bacteria in deep-sea hydrothermal vents. While Mars was already fully wet, on Earth, there were no plants or animals, just microscopic life trying to survive. So, Mars took the lead in the life game. It had a much thicker atmosphere, which could have trapped enough heat to keep water liquid. Valley networks, huge traces across the red landscape, show us the incredible story of rainfall, rivers, and lakes. Huge asteroids were still hitting Mars at the time, and they could have brought organic molecules with them. But if that's true, what happened and where did life go? A recent NASA study suggests that the answer is more complicated than we thought. Astronomers believe that something drastic happened to Mars, like boom, and its cozy climate was gone, its atmosphere thinned. Without a strong magnetic field like Earth's to protect it, solar radiation stripped away the air, leaving Mars cold and dry. The ocean simply evaporated. Some of the water escaped into space while the rest froze underground or became locked in polar ice caps. Today, all that remains is a ghostly memory, dry channels and salty mineral deposits. But it looks like the transition wasn't sudden at all. It was slow and gradual. The planet was changing from wet and warm to cold and dry over millions of years. In fact, Mars kept its ocean even after the temperatures dropped to freezing. Some parts of Mars, especially the northern lowlands, might have remained wet for many, many centuries. Shouldn't the water freeze when it gets below 32 degrees Fahrenheit? Well, yeah. But there are many reasons why this miracle happened, like Mars's thick atmosphere and warm water traveling through currents. And during that time we mentioned before, from Noachian to the late Hesperian, life could have found a way. Microbes on Earth thrive in some of the harshest places, beneath Antarctic ice, in deep sea vents, in toxic volcanic lakes. Hey, life doesn't care. So these times in Martian history would be amazing for it. But don't be mistaken, Mars was never a paradise. Even during its cozy times, it wasn't as lush and green as we might imagine. In its early days, Mars was something more extreme, something closer to the young Earth. During the Noachian period, it was warm yet wet. Then, the climate shifted into the Hesperian period. Oceans were stretching across the northern lowlands. Temperatures dropped, and snow piled high, forming massive glaciers in the south, transforming the planet into an icy world. Finding microscopic life at that time is possible, but an intelligent civilization? That's less likely. The square that went viral isn't evidence for intelligent life yet, and here's why. First things first, people freak out because nature doesn't make straight lines. But that's not really true. Actually, nature does it all the time. For example, here on Earth, we have the Giant's Causeway in Northern Ireland, a beautiful field of hexagonal basalt columns. These are completely natural. They're formed by volcanic activity. There's also the Devil's Tower in Wyoming. Hey, remember it from the Close Encounters movie in the 80s? That's a symmetrical rock formation, and it was created by erosion. However, if we looked at these things from space, they'd look artificial. So, what is the square? How about a fracture pattern in the rock or some terrain that's broken apart along straight lines due to stress? This happens on Earth all the time, when rock expands and contracts over time. And on Mars, the surface is just constantly battered by meteors, winds, and extreme temperature shifts. No wonder rock would get stressed. What happens here is another case of pareidolia. It's our brain's favorite thing, to spot patterns in something random. Hey, we evolved like this. So sometimes we might look at natural objects and see insane stuff. Faces on trees, animals in clouds, shapes, and so on. Besides, NASA has been photographing Mars for decades. We have high-resolution images of craters, mountains, valleys, riverbeds, everything. Wouldn't an ancient civilization leave us, well, something better than some square-like rock? Even though things erode over time, we'd find more signs, roads, foundations, artifacts, ruins, or at least something. Though, to be fair, we do see something. The square wouldn't be the first time Mars has played tricks on us. Over the years, we've spotted everything, from tunnels to carved faces, even Bigfoot. Or this doorway, for example, a perfectly cut rectangular opening. That's what people saw when NASA's Curiosity rover sent back an image of the East Cliffs on Mount Sharp. It's almost like an ancient passage leading deep into the surface. You just need to go in and find some fantastic underground base. Well, NASA decided to take a closer look at it. It turns out it's just 12 inches tall and 16 inches wide, the size of a dog door. That's because what we're looking at isn't a doorway, but an open fracture, a break in the rock that happens naturally over time. These kinds of cracks are extremely common, both on Earth and on Mars. They form when bedrock is stressed, expands, contracts, or gets eroded by wind and time. If you walk through a desert here on Earth, you'd see plenty of similar shapes. Canyons, cliffs, and even boulders have fractures that, from the right angle, might look like doorways. They're just not getting photographed by NASA. Also, the straightness of lines turns out to be just a trick of perspective. If you zoom out, you'll see that it's just one small break in a much bigger rock formation. Or the infamous Cydonia face. The photo was taken back in 1976 by NASA's Viking 1 orbiter when it was scanning Mars. In the region known as Cydonia, it captured what looked like a massive humanoid face, a rocky formation about 1.2 miles long. And this one face inspired books, documentaries, movies, and podcasts. But when NASA's Viking orbiters first took pictures of Cydonia, the cameras weren't super advanced. The image of the face had a low resolution and made the details fuzzy. NASA's later missions had far better cameras, and when Mars Global Surveyor revisited Cydonia in 2001, the truth was undeniable. The face was just a hill, a lumpy rock formation with ridges and depressions carved by wind and erosion. And in 2006, during another mission, a colored image with insanely high detail was made. No traces of face left there whatsoever. That's another pareidolia trick for you. Now, Mars has plenty of secrets left to uncover, but they will be related to its fascinating history, not some secret ancient civilization. The conclusion is, don't trust everything you see online. Sometimes a mysterious rock is just a rock. Recently, scientists have made an astounding discovery that can change the entire course of Mars exploration. Apparently, there are oceans of liquid water on the red planet, so the future looks bright. We could use this water to support future missions, and then even relocate to Mars since we wouldn't need to worry about where to get this precious liquid, right? Well, there's one big problem. These oceans of liquid water are in Mars, so deep inside that we aren't likely to get there. At least that's what a new analysis of seismic data collected by the Mars InSight lander claims. Huge reserves of liquid water seem to be the best explanation for some seismic quirks of the red planet. So all this precious water is out of our reach. But we need to find it to solve the puzzle of the aquatic history of our blushing, dusty neighbor. And the first thing we need to do is identify where the water is and how much of it the planet is hiding.
Navigation has confirmed that the parachute has deployed and we are seeing significant deceleration.
Now, our rovers are scurrying about on the surface of the red planet, gathering all the available data on the planet's surface geology. And it's getting increasingly obvious that Mars was once covered with water. Many factors, from Martian terrains to ancient dry lake beds and deltas, suggest that there was a time when the planet was quite soppy. These days, there's still some water on and right below the surface of Mars, but it's in the form of ice and nowhere near what Mars had in the ancient past. To understand how much of it could have been on the red planet billions of years ago, we must know where all this water went. There are two spots where the water could have gone: into space or toward the interior of Mars. Then it could have been isolated as either liquid reservoirs or ice deposits. Currently, we don't have any way of measuring how much water once leaked away. But now, we finally can find out more about the gooey center of the red planet. All thanks to the Mars InSight lander. It isn't operating anymore, but from November 2018 to December 2022, it was listening to the hums and rumbles and monitoring the activity below its feet. The thing is, acoustic waves generated by seismic activity deep inside the planet can change according to the composition and density of the material these waves are moving through. And scientists can get a lot of information analyzing the behavior of seismic waves. In this case, they used a model similar to those used to map underground oil fields and aquifers on our home planet. Then, with the help of this model, they analyzed the data gathered by InSight on Mars. They discovered that the best explanation could be that there was a layer of fractured rocks whose cracks were filled with water deep under the surface of the red planet. That layer could be at a depth of 7 to 12 miles. That's why it would be extremely tricky for future missions to get to it. And still, the new discovery could help us understand the Martian water cycle. Confirming the existence of a large reservoir of liquid water can help us sneak a peek at what the climate on Mars used to be or what it could be like one day. And if once Mars had a lot of water, it could have been habitable in the ancient past and might become isn't likely to be a lot of water ice in the upper crust of the planet, at least in the region around the lander. But if it turns out that there is a water-rich layer deep below the surface and stretching around the entire globe of the planet, then there would be enough water to fill ancient ocean beds and even more. Now, Mars isn't the only place outside Earth where there is water or where we might one day find water. Take the good old Moon, for example. On Earth's natural satellite, water can be found all over the surface, but it's not the water you might be imagining. On the Moon, water remains mostly as ice, and it's distributed unevenly. For example, the poles of the Moon are the regions that never receive sunlight. This is the reason they're extremely cold, and it's no wonder there's a lot of ice there. The ice in these areas is often mixed with the lunar soil and hiding deep below the surface. Then there's Enceladus, the sixth largest moon of Saturn. In reality, it's not that large, just 314 miles across. In other words, this moon is small enough to fit inside Arizona. Ooh, we should try that. Well, interestingly, when the Cassini space probe first arrived at Saturn, researchers were expecting Enceladus to be a frozen ball of ice. But what they saw was plumes of icy particles and water vapor erupting from geysers on the moon's surface. It was clear that there was a massive ocean between the moon's rocky core and its icy shell. Then there's Jupiter's moon Europa. Scientists think that this world is one of the most promising places in the solar system when it comes to searching for new life forms. That's because Europa has a huge saltwater ocean as deep as 40 to 100 miles. And even though it's under a layer of ice that is likely to be 10 to 20 miles thick, it's still potentially habitable. Astronomers believe that plumes of water might erupt from cracks in the ice shell and release the contents of the Moon's ocean into space. The temperature, pressure, and chemistry are very different on Europa, and astronomers aren't sure yet how the ice behaves there. That's the main reason they haven't figured out yet how deep or large the water reservoirs on Europa are and how long they need to refreeze. But out of all the places where we could find water in the universe, the most bizarre is probably open space. In 2011, two teams of astronomers discovered a cloud of water floating freely among stars. It was the largest and farthest reservoir of water ever detected. So this massive cloud of water vapor surrounds a black hole. But not just any black hole. This one's a quasar, located 12 billion light-years from Earth. The conditions around this quasar must be really special to create such an enormous amount of water. This cloud contains 140 trillion times the volume of all the water on Earth. That's enough to give every person on the planet a whole planet's worth of water 20,000 times over. Sounds wild, doesn't it? But there's something even cooler. Astronomers think this water cloud formed just 1.6 billion years after the universe began. This discovery is yet another sign that water has been around all over the universe, even in its early days. But here's the kicker. Until they found this, scientists had never detected water vapor so far back in time. Sure, there's water in our Milky Way galaxy, but most of it's frozen solid in ice. This discovery really pushes the boundaries of what we know about water in the universe.